Let's look at Nesterov momentum. So from now on, as we're looking at momentum, we're going to go ahead and add in this dampening, this 1 minus beta here. So let's look at the code for this looks exactly like this. So somewhere earlier, we're going to initialize v equals 0. And then we'll have this loop where we're going through, and this is the optimization. So every time through our diagram when we do the optimization, this is the optimization that happens. So let's break this out a little bit. So let's convert this to, so expanding this, theta equals theta minus lambda times beta v plus 1 minus beta times the derivative. What I want you to note is there are two parts to this update to theta. One part is independent of the gradient because this is the old value of b. So we could have instead written it like this. Theta equals theta minus lambda beta v plus 1 minus beta times the partial derivative, and then we could go ahead and update v. So if this is our code, we look at a diagram. This is some theta sub I. Here we are. So let's say we are here. And we are going to take a step. So the step that we would normally calculate from here is this. We would take the current gradient and add it to our velocity and obtain this new location. So there are two components to this, right? This vector we end up here. There's a first component, which is this beta v, lambda beta v component, right? So this lambda beta v component is from our velocity, right? So we can look at our old velocity. So let's say we have, this is composed of two vectors. So one vector is the lambda beta v, and the other vector is 1 minus beta times. And that gives us this vector here, where this vector and this vector are supposed to be the same thing. So what are we doing? Basically, we're saying, here we are. I know there are two components to how I'm going to updating theta. One component is my accumulated velocity. The second component is my gradient from where I'm standing right now, right, from this location. The Nesterov update says, you know what? We know we're going to be updating based on the v. So Nesterov says, let's go ahead and first update theta based on our v. Now that we have actually updated theta, so we have actually moved somewhat over here, right? In this case, our vector for lambda beta v, we're saying is something like, over this. So it has a horizontal, so we're like here, okay? Now, go ahead and calculate the derivative. So we can say, okay, now we're going to update v equals beta v plus 1 minus beta times the derivative. The key is we're calculating the derivative after having updated theta. So we are getting a better estimation of what this gradient is going to be, because we know that we're going to be updating theta based on these two components, based on the gradient and based on this historical velocity. So why not go ahead and take a step, right? Take a partial step where the velocity will take us and look there and see what the gradient will give us. So it's like we're kind of two-step updating theta, because that's now we're going to go update theta, which is theta minus lambda times 1 minus beta, times now this same updated derivative. So the key part is this derivative and this derivative are different because this one has a theta taken from having already updated based on the velocity. So this is the Nesterov change to momentum, which says basically, again, take a step first before you calculate the derivative based on the accumulated velocity.